Good evening, everyone. So, welcome to the week 9th of water and wastewater treatment. I am Mansi Tripathi. I am your TA for the doubt solving sessions. Okay, so here we'll be solving your doubts as well as we'll solve some questions which are related to the assignment as well as the examinations. Okay, so I'll share my screen, then we'll start the doubt solving session. Give me a moment to share my screen. So, I hope my screen is visible and I am quite audible to you. So, our course name is Water and Wastewater Treatment. So, this is week 9 of problem solving session. We'll be solving some theoretical as well as numerical questions. So, the question number 1 is, which of the following is not a mechanism for removal of impurities in depth filtration? So, what is depth filtration? Depth filtration means the whole depth of the bed will be used for filtration, whole depth. So this happens in which type of filtration? Rapid sand filtration. And what happens in the slow sand filtration? Only the top few layers, only the top layer will be used in slow sand filtration. So here we are talking about depth filtration. It means the whole depth of the system is used for the filtration. So which of the following is not mechanism of removal? Interception, diffusion, flocculation, and solubilization. When we talk about depth filtration, there will be few mechanisms by which it will be captured. So interception is the common mechanism. Like if some particle is coming, it will be intercepted if the size of the particle is bigger. But other mechanism they may change. So which of the following is not a mechanism of removal of impurities? Answer is solubilization. So what is solubilization? What happens when there are bacteria over the top layer, which happens in slow sand filtration? Let's make a slow sand filtration. There will be bacteria in the top layer. So they will capture the organic matter and they will solubilize it. And the solubilized organic matter will flow down. So this is what happens in slow sand filtration where there is a layer of bacteria. But in depth filtration, this does not happen because the speed is very fast, so it won't get any chance to get solubilized. Let's move towards next question. In the context of removal of particle by filtration, looking at the following picture, please mark the correct statement. So this is a picture between transport efficiency versus particle diameter, and what will happen with respect to particle diameter and transport efficiency. Different types of mechanisms are there: sedimentation, interception, diffusion. Sedimentation when rho is 1050, when this is 2650. What will happen? So first option is, if the particle size is around 10 raised to power minus 8, means this predominant removal mechanism will be diffusion. So predominant mechanism of removal will be diffusion. So here we can see, yeah, diffusion is there. This line is coming. Next is, if the particle size is around 10 raised to power 5, means here predominant removal mechanism will be interception. So yes, it's above diffusion, so it will be third option is if the particle size is around 10 raised to power minus 8, predominant removal mechanism is interception. But here no interception is coming. So this statement is totally wrong. D option is if the particle size is around 10 raised to power 5, predominant removal mechanism will be diffusion. But diffusion is below interception, so it won't happen. So we'll see the solution. So the answer is option A and option B. When the particle size is minus 8, this will happen, and this is the line of diffusion. So when the particle size is very small, it will diffuse. Okay, their diffusion will happen. But if the particle size is larger, for example 10 raised to power minus 5, interception will happen. So option C and D are incorrect. Moving towards next question. If the raw water turbidity is less than 10 NTU, turbidity is less, then which of the following treatment will be favorable? Coagulation, flocculation, sedimentation, filtration, disinfection. We have to arrange them. So if the turbidity is less than 10 NTU, means it's quite clear water, then which of the following function we have to do? We'll see the answer. Answer is coagulation, flocculation, filtration and disinfection. Okay, because the turbidity is very less, sedimentation is not required. Whatever will settle in the flocculation chamber, after that we will directly filter it, the supernatant, then we will just directly disinfect it. Disinfection will always be there. Okay, so disinfection will always be there at the end. Next question is, if the sand media has uniformly distributed particle size, then it is best suited for which of the following? So the particle size is uniformly distributed. So what type of thing it will be there? Slow, rapid, or particle size distribution does not affect? So that's wrong obviously, or none of the above. So answer will be either A or B. So if the sand media is uniformly distributed, means the particle size of all the particles is almost similar. Then which type of filter it will be? So the answer is rapid sand filtration. Okay, because we are using the whole depth, that is first thing, and we are backwashing here also. So while backwashing, what will happen? Smaller size particle will go at the top and the larger size particle will come at the bottom. So the filter, like normally what we do? Normally what happens? While designing any filter, you will design it like this only. You will put bigger particles at the top, little smaller bottom, and very small at the bottom. So this is means here it is not uniformly distributed. But if during backwash, what will happen? Bigger particle will be reversed. The bigger size particle will come at the bottom and the smaller will go at the top. So it will disrupt the efficiency of the filter. That is why when we go for uniformly distributed particle, it's better to use rapid sand filtration. In rapid sand filtration, use uniformly distributed particle. So even if there is high backwash velocity, this problem won't happen. Let's move towards next question. Look at the following picture after the duration of 90 hours. So look at the time this. So after 90 hours means here. Which of the following operation would you suggest in depth filter? Effluent turbidity. Here we are talking about effluent turbidity. filter ripening. So at the time of filter ripening stage, we do not use the water. So first there will be little bit of increase in turbidity in the effluent. After that only it will start decreasing. Okay, so at this stage what we will do? This is rapid sand filtration. So what do we do if the turbidity started increasing after some time? Of course, we will backwash it. So backwashing is the correct option. We cannot change the filter media. Filtration we cannot continue because it will increase. Scraping the top layer, no, it's not slow sand filter. So what we will do is backwashing. We're talking about depth filter. So scraping the top layer won't work. So we'll do backwashing. So that after backwashing, this thing will again start like this. Okay, similar thing will start. Let's move towards next question. This is a numerical question. Please note down all the values. A sand filter is to be provided in water treatment plants that caters to a population of 1.2 lakh. The average water demand is 140 LPCT and the rate of filtration is 16 meter cube per meter square per hour. If the design follows filter water for storage to meet the backwashing requirement and the filter bed is required to expand by 0.4 meters, the required backwash velocity will be. Here we have to calculate the VB. We have the porosity of the unexpanded bed, coefficient of drag CD we have, kinematic viscosity we have, depth of filter media we have, mean diameter of the filter media particles we have, specific gravity we have, and density of water also we have. So this will be represented by this. We have to calculate the VB. So please note down the value so that we can move further. Okay, we will move towards the solution. So this is the solution for that. Specific gravity of filter media is given 2.5, which is equal to rho S upon rho W, means density of the filter media particles divided by density of water. So what is density of filter media particle? It will be 2.5 into 1000, that is 2500 kg per meter cube. So now next thing will be the calculation of head loss. So for calculating the head loss, the formula that we will use is rho S minus rho W upon whole upon rho W into 1 minus porosity into the depth. So this will give us the head loss, that is 0.75. Now first of all we will calculate the settling velocity using the Stokes law, then we will check with the Reynolds number. So when we are using the Stokes law, so this is the velocity formula. that we will give 3 4 into specific gravity minus 1 into acceleration due to gravity into diameter of particle. All the units will be uniform, okay? Divided by 3 into CD whole under root. So we got our velocity is as 0.048 meter per second. So this is settling velocity. This is not the backwash velocity. This is the settling velocity. From here we will get the Reynolds number, which came out as 28.66. Now what is porosity of the expanded band? We have all the values. We have all the things. We have expanded bed depth because it is expanding by 0.4 meter. It was written right, 0.4 meter. So depth of expanded bed is 1.4. We have everything, so we got porosity. Now we know that expanded bed porosity is equal to backwash velocity. It is related to backwash velocity and the settling velocity by this relation, this empirical relation. When we are putting all the values in that, we are getting the backwash velocity as 0.012 meter per second. So this is our answer. Okay. Step by step we can get to this answer. Next question is, the separation limit for membrane is determined by lowest that it can separate. When we talk about membrane filtration, we determine in terms of particular value that this is the maximum width it can separate or not, like that. So in what terms a membrane can be used? Molecular weight, ionic weight, mass, or none of the above? So the answer is molecular weight. Okay, so you might have seen in many membranes when we say RO membrane or anything, like for example, if we talk about RO membrane, it has the separation limit of 200 to 400 Dalton or gram per mole. So if the particle is having size more than that particular molecular weight, it will be retained in the concentrate and rest of the things will pass. So what happens in RO membrane? If this is the RO membrane, inlet is coming, some outlet, and some will be retained, which we call reject. So there will be many types of particles, many molecular weight. The one which is allowing will go here and the rest of the thing will go here. Okay, this is how it works in membrane. The next question is, the degree of selectivity of membrane is largely depends upon, there will be something the membrane will pass but others won't. So what is the degree of selectivity, on what factor it depends upon? The membrane charge, porosity, volatility, of or all of the above. So the answer is membrane charge and porosity of membrane. Porosity of the membrane you can easily understand. If it is highly porous, it will allow more particles. Next is membrane charge. So there sometimes in some types of membrane, especially the ion exchange membrane, it will have some functional group. So it will allow only a particular functional group to change position. So that depends upon the membrane charge. Next question is, dialysis in our kidneys is concentration driven separation process, thermally driven, pressure driven, or separation driven. So what happens when we allow any membrane process? Okay, there will be many processes by which it allows the separation. Let's talk about, like, if we are putting any membrane and we are putting some pressure on this side, some pressure we are putting on this side. Then the water will start flowing like this. So this is what we call pressure driven. Even if the concentration is lower here, it will move like this. So this is pressure driven. Next is concentration driven. The same type of membrane we are putting, here we are putting high concentration. Here we are putting low concentration. The things will move from one direction to another. So this is called concentration driven. And what is thermally driven? Thermally driven we have studied in laws of thermodynamics. So, or for example, if you have a glass of water, the temperature is 50 degrees Celsius, outside temperature is 35 degrees Celsius. So, it will exchange heat until both the temperatures are similar. So, this is thermally driven separation process or thermal driven process, not separation process exactly. So, dialysis of our kidneys is concentration driven separation process. Okay, so it will filter the water that goes inside, it will retain water, and the high concentration toxicity it will collect at one side and it will flush it. Okay, so that's all for today. If you have any doubt, you can ask.